Question 1. John has a box of candies. On the first day, he ate exactly half and gave one to his little sister. On the second day, he exactly half again he ate, and then gave one to his little sister. On the third day, exactly half he ate and gave one to his little sister, at which point he had no candies remaining. How many candies were in the box at the start? So this is a question that's essentially just cutting things in half, and I'll sort of do it in a very careful way so you can understand. So on the first day, he starts off with x, right? But he ate half, so he ate x over 2. And then he also gives one away. So that's basically how many he gives away or eats. So the remaining would be his initial x minus that x over 2 and minus that 1. And this is x over 2 minus 1. And then now on day 2, it's the same story, but just these values are going to be a little bit different. This time, he eats half of what's left. So he eats half of this x minus 1 over 2 divided by 2, this guy right here. But he also gives one away. So what does he have left? He has this initial amount, right, minus this guy, which is x over 2 minus 1 over 2. And then, of course, you also have to subtract the one that he gave to his sister, like that. Right? So I'll let you guys do all the math, and when you do, it simplifies to this over here, x over 4 minus 3 over 2. And then on day 3, same thing. He takes his x over 4, 3 over 2, and he eats half of that, and then he gives one to his sister. So then it would be the same kind of story where you have this original amount minus this amount, which is x over 4 minus 3 over 2, and then minus the one that he gave to his sister. And this, they're saying, is equal to 0. So this is equal to 0. And that basically gives us an equation, and that equation will allow us to solve for x. So when you do all this math, you basically get down to x over 8 minus 7 over 4. So I guess you put the 7 over 4 on the other side, and then you have x over 8. So 4x would equal 56, and therefore x would equal 14. And that is the answer to this question. Question 2. A palindrome is a whole number whose digits are the same when read backwards or forwards, left to right, right to left. For example, 565, 7887 are palindromes. Find the smallest 6-digit palindrome divisible by 12. 1, 2, 3, 4, 5, 6 digits. And because it's a palindrome, it'll be of the form AA, BB, CC. And they're saying it's divisible by 12. Well, if a number is divisible by 12, it is divisible by 3, and it is also divisible by 4. So this number here has to be divisible by 3 and by 4. Okay, well, let's talk about each one separately. First, let's talk about it being divisible by 3, and then we will turn our attention to it being divisible by 4 over here. Okay, if it's divisible by 3, then according to, there's many divisibility rules, but the one that involves 3 says that the sum of the digits would be divisible by 3. Sum of digits would be divisible by 3. So in this case, this number here, the sum of the digits would basically be 2a plus 2b plus 2c. Now, if we factor out a 2, it's a plus b plus c. Now, this is not divisible by 3, so this must be divisible by 3. So that can be either 3, 6, 9, 12, 15, 18, 21, 24, and 27. Because the largest it could be is 27 if all three, A, B, and C, were 9. So I think that's the extent of it. Okay, it still doesn't give me my answer, but we are working toward it. Now let's turn our attention to the divisible by 4 criteria. If that is the case, then that means in this number, the last two numbers must be divisible by 4. So, for example, if you had the number 1, 2, 3, 4, 5, 6, this number has to be divisible by 4. That's what I mean by the last two. So in this case, it's BA, but BA is really 10B plus A, right? We actually want the number, not the digits. So 10B plus A has to be divisible by 4. So it's either going to be 4 or 8 or 12 or 16 or 20 or 24, 28, 32. Oh, and then it just keeps on going. I mean, all the way till 92, 96, which is the largest two-digit number divisible by 4. So we got a lot of criteria, a lot of choices with our criteria. So now we have to combine this guy and this guy and see what we can do. Now, one thing I noticed in this question that is going to make our life a little bit easier is that they want the smallest. So because they want the smallest, we can just concentrate on the smallest numbers. So if I concentrate on the smallest numbers, I want this number to be as small as possible, right? Because that's going to make the smallest 6-digit number. But that number cannot be a 0, because if it's a 0, then it would not be a 6-digit number. Okay, so if this number is the same as this number, so it can't be a 0, so the smallest it could be is a 1. That is definitely the smallest number. But unfortunately, none of these have 1 as the A. You notice how 10B plus A, this is the B and this is the A. You got it? So if you notice, none of the A's are a 1. So the 1 is out. Okay, well, let's see if this could be a 2. Well, we definitely have a lot of 2's in there. We've got this one here, and then we'll have this one, and we'll have several. So let's start with this one here. So if that is chosen, then that means this is going to be a 1. So that is B. And then our C, we have to choose a C so that we fulfill this criteria, that A plus B plus C is equal to 0. So in this case, we have A, B, and C. We have A as 2, B as 1, and then C, what's the smallest I can make it to make it A plus B plus C divisible by 3? Well, 2 plus 1, if I make that 0, then that's going to be 3, and 3 is, of course, divisible by 3. And there you go. And that's pretty much how you do this, and that's the smallest. And that is the key to this question, I think, because obviously, as you can see, there's numerous other palindromes you could make with this criteria and that criteria, but they really just want the smallest. So once you get to this, you're pretty much done with the question. Initially, there are 4 red balls, 7 green, 8 blue, 10 white, and 11 black. Every minute, we may repaint one of the balls into any of the other 4 colors. What is the minimum number of minutes after which the number of balls of each of the 5 colors is the same? Notice the spelling of colors, because there's a U in there. You know this is from Canada. All right, so let's put this all out. We have how many red? 4 of those, and then 7 green. So green, 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 and so on. All right, so now let's play this game here of trying to paint everything the same. Now, first of all, we have to conclude what is the number. So what I mean by that is what is the number of colors that when everything is the same. So initially there's 4, 7, 8, 10, and 11, right? So if you add them all up, 4 plus 7 plus 8 plus 10 plus 11, and then divide by 1, 2, 3, 5 of these colors, right? That's going to give you what the average would be. And this is 40 over 5, so that's 8. So when that means that when this is all done, all colors should have 8. There should be 8 balls of each color for everything to be same. Okay, that helps, right? That definitely helps us out. Okay, so now let's start doing that. Let's start making this process work. Okay, so one step at a time. Now, I want this 11 here to knock down to 8. So I'm going to take this guy, and this guy away. That wouldn't make it down to 8, correct? And then I'm going to bring them over here, but then paint them red. So they would be here. So that means that now we have 7 reds. You see what's happening here? Okay, so then here we have 10. I'm going to take one away and bring it over here. This brings this down to 9, but then this number goes up to 8 because I took the balls over to this part and painted them. So now this is done. We've got 8 red. Now I'm going to take away another one of these guys and bring it over here and paint it green. So now this number goes up to 8. But this number here went down to 8. And I think we're done because this is 8, this is already 8, that's 8, and that's 8. So all the colors have 8 balls. And now how many did we move? We moved 1, 2, 3, 4, 5. So we had to move those 5 and paint them a different color in order for this to happen. So that was the minimum. So the answer to this question is 5. In the diagram, triangle ABC lies between two parallel lines as shown. If segment AC has 5 as length, what is the segment AB? All right. Well, the first thing I think is we'll need to calculate this angle right here. So the total is 180. So if that angle, let's say I call it X, 73 plus 17 would be, plus X would be 180. So that gives me X is equal to 90. All right. What that basically means is that this is a right angle. I put in a big right angle there. All right. Now let's calculate any other angles if I can. Let's see here. Well, you guys know that whole complement supplement thing, that in this, because these lines are parallel, that's a very important part of the question. That means this angle is the same as that angle. So this angle here, right here, is 73. Now this is already 13, so that means this guy in here would be 73 minus 13. And that's 60. So that angle in there is 60. And therefore this angle is 30. Okay, so that means that is a 30, 60, 90 triangle, which is very helpful. So let me just put in the C, B, and A. Now, as you all know, the ratio of the sides of a 30, 60, 90 triangle are 1 and root 3. So we are given the distance, I believe, for one of these guys. I think CA, that one's 5. And what do they want? AB. Okay, that shouldn't be a problem. CA over AB is 5 over AB, and that is going to be 1 over 2 according to these ratios. Yeah, so that means that AB is equal to 10.